So, in inverse transform technique, we have derived an equation for exponential distribution, uniform distribution, Weibull distribution, and triangular distribution. So, this ends inverse transform technique. Next one is acceptance rejection technique. So, as the name says, acceptance rejection technique, here if a particular customer comes within time, okay, customer comes within time, say for example my closing time is 10 a.m. So if a customer comes within 10 a.m. I will accept this customer. If he comes at maybe say 10:01 a.m. I will reject that customer. So say for example if I have 5 customers already in the grocery store before 10 a.m., when will I accept, whether will I accept the 6th customer? If the 6th customer is coming within this 10 a.m., the number of customers will be incremented to 6. If the 6th customer is not coming within this 10 a.m., my number of customers in the grocery store will be 5. So this is acceptance rejection technique. Number of customers in a system is decided by acceptance rejection technique. Number of customers, if they are within time, say for example n, within time, then number of customers in the grocery store or in the system is n. If this n plus 1th customer is within time, then number of customers will be n plus 1. If this n plus 1th customer is coming out of my closing time, then I will reject this n plus 1th customer and I will say that number of customers is n. Accept that n is number of customers is n. When will I accept number of customers is n plus 1? When will I reject number of customers as n plus 1? When this n plus 1th customer is within time, then I accept that n plus 1 customers are in the system. When this n plus 1 customers, n plus 1th customer is out of time, that is if he is coming after 10 o'clock, then I will reject this n plus 1th customer and I say that number of customers in the system is n. This is how acceptance rejection technique works. So let us have a procedure for generating a Poisson random variate capital N. So here our goal in this acceptance rejection technique is to generate a Poisson random variate which is indicated by capital N. So these are the 3 steps which we are going to use to generate this Poisson random variate capital N. So first step is set small n is equal to 0 and capital P is equal to 1. Capital P is product. N is number of customers. So number of customers, first I am going to consider them as 0. So small n is equal to 0, product P is equal to 1. Step 2, generate some random number Rn plus 1. This will be a new random number which we generate. Replace P by P into Rn plus 1. So, I am multiplying P, that is 1, into new random number. Now, step 3. If P is less than or equal to e to the power of minus alpha, then accept capital N is equal to small n. That means I will declare that number of customers in the system is small n. Capital N is equal to small n. Otherwise, reject the current n and increase n by 1 and return to step 2. So here is the question. Generate 3 Poisson variates with alpha is equal to 0.2 with random numbers. We are given with 5 random numbers using acceptance rejection technique. So step 1, as we know, set n is equal to 0 and P is equal to 1. Step 2, take this random number, first random number 0.4357 and multiply it to previous P, that is 1. So now P value will be 0.4357 and alpha is given in the question that it is 0.2. So e to the power of minus 0.2 is 0.8187. So check whether P is less than e to the power of minus alpha. So P is 0.4357. E to the power of minus alpha is 0.8187. So this is less than this? Yes. So accept n is equal to small n, that is equal to 0. So first random variate is 0, x1. Then go to second random number. So again start with set n is equal to 0, p is equal to 1, p is equal to p into r2. Why I am doing this again is I have to generate second random variate. They have asked us to generate 3 Poisson variates. So I am going to generate second random variate. So for that I will set n is equal to 0, p is equal to 1, p is equal to p into r2. So here R2 is 0.4146. So multiply that with 1, you are going to get 0.4146. So 0.8187 is e to the power of minus 0.2 as usual. So 0.4146 is less than 0.8187. Hence accept capital N is equal to small n is equal to 0. So I am accepting this as this is less than. So x2 second random variate we are generating, that is x2 is equal to 0. Now it is time to generate third random variate. So again go for step 1. Set n is equal to 0, p is equal to 1. Step 2, p is equal to p into r3. So next random number as we took here is 0.8353. So when I consider 0.8353, so p value will be 0.8353 and e to the power of minus alpha value is 0.8187. So p is not less than e to the power of minus alpha. So should we accept capital N is small n? No. Hence, it is rejection time capital N is equal to small n is equal to 0. So, what I am supposed to do? I am supposed to again go back to step 2 with incrementing n is equal to 1. So, p is equal to previous p. Previous p is 0.8353 multiplied by now new random number. Next random number is 0.9952. So, I am going to get p is equal to 0.8312. Step 3, that is e to the power of minus alpha. Now 0.8312 is not less than 0.8187. So again we are supposed to reject and go to step 2. Increment n is equal to 2. So reject n is equal to 1 and increment n is equal to 2 and return to step 2. So step 2 is again multiply a new random number with the previous p value 0.8312 multiplied by 0.8004. P is equal to 0.6653. Now step 3, compare p and e to the power of minus alpha. So it is less than, so accept capital N is equal to small n, that is equal to 2. What was the value for n here? 2. So that I am going to accept. That is the third random variate x3 is equal to 2. This ends the problem. This is very important question.